So in this video and the next four, we're going to add the logic for our 5 methods that we created in the previous video. And remember, the first 2 of these are just called while the game is being set up. So they're just going to be called once, and then the other 3 are going to be called each time the game cycle runs. So let's just get to it here. Set variable values, get rid of this throw new not implemented, and first thing we're going to set the maximum number of particles to 2,000, and this could be anything, but the more you put in, the nicer the explosion might look, but the harder it's going to be for the system to keep up with it. Then position X, we're going to set this to be window client bounds dot width divided by 2. So that's right in the middle from left to right. And position dot Y, probably know where this is going, window dot client bounds dot height divided by 2. So there we go. So it's right in the middle. And zoom ahead. And here we are. So we've got the rest of these values here. Now the boom pause, what that is the position of the actual little bomb image. And that's almost in the center also, but it's a little bit offset. So it's the X position minus 100 from the center, and the Y position is minus 110 from the center. So close to the middle, but not exactly. And then we've got an initial particle speed. We've got an initial thing calling smoke speed, so we'll get to that in a little bit. Particle scale, we're setting that at 0.5, so they're going to start out kind of small compared to the images. And smoke scale much larger, so smoke is going to be more of a billowy kind of thing. Particle gravity, we're setting this as 0.1. It's just relative to what's going on. You can set these just based on how things look, and once you run this a few times, you'll get a better feel for that. Smoke gravity of 0, which means the smoke particles, those that we designate as smoke, are not really going to be affected by gravity. Now, smoke is particles, they are affected by gravity, but because they're so light, the individual particles, they tend to not really respond to gravity in a real time. They settle over time, which is gravity, but we're just going to set it at 0 because this explosion is only going to run for a few seconds. And then the particle scale change rate, 1.01. If the rate was 1, then they would not change. That's like 100%. So each game cycle, they're going to get 1% bigger. And then the smoke scale change rate is equal to 1.03. Smoke's going to get bigger a little faster than the particles do. And I say a little faster. This is going to multiply each game cycle, so it actually turns out to be quite a bit faster. Now we set up the system to have 7 different particle types, and those are particle type 01 through 07. That's what's listed here. And we brought in all the different particles we had, but we're just choosing a few of them to use for this. So we've got the 00 and the 01s. Remember, those are mostly opaque. And then that last one down there at the bottom is a 03, which is mostly transparent. That's it for set variable values. And now we're going to set the sprite values. Okay. So in the set sprite values, we'll get rid of that line. Now here is where we're going to set up the different particle types. So we're going to create these boundary variables to divide the sprites up into a bunch of different groups. So we're going to set the upper and lower boundaries of some groups here. And we start with upper boundary underscore 01. Now lower boundary 01 is going to be right at the start of the particles, so we don't really need that one. Now we're using the max sprites variable here to kind of keep from hard coding this a little bit, but there's still a little bit of hard coding because we do have some numbers here. If we were going to really keep from hard coding, we wouldn't have any numbers showing up at all. So these divided by 8s and 2, 3, 4, 5 and all that would be replaced by other variables, and we'd create loops. And we can get really complicated here to avoid hard coding altogether. But that's a little too far advanced, a little too abstract for what we're going to do. But what you can see here is we've just created these lower boundaries and upper boundaries that we've come in and segmented out. So the first group of sprites will be assigned to the first particle sprite, and then the next group will be to the next particle type, and so on through all the different particle types. So that's it for those. Now the next thing we need to do is set up the speed. Now we're going to set up the lower boundary on the speed as minus 200 times whatever the particle speed is set at, and an upper boundary as 200 times whatever the particle speed is. Now this is going to be used in a calculation later, so these particle speeds are not going to be anywhere near this fast when they get into the game. If they were, the particles would just fly off the screen in one shot, but we want to use some larger numbers so that we can get some granularity to this. So now let's skip ahead a little bit, and here we've got the lower and upper boundaries of the particle speed, the lower and upper boundaries of the smoke speed. And the smoke is just a different type of particle. As you can probably guess, it's that last one with a lot of transparency in it. Then we've got an upper boundary of a particle scale that we've set up here to be an integer of 80 times the particle scale, and a lower and upper boundary of the smoke scale, which is a little bit smaller number. So those are just some complex ways we've set up this number so that we can have a range in the scale of how big these particles come out and how fast they're moving and things like that. So now we're going to initialize our array. So particle sprite equals new particle sprite. And then in square brackets, max sprites, semicolon. Okay, so now we have to initialize the individual particles. So we're going to say for int I equals 0, I is less than the upper boundary of the first segment, and then I plus plus. This is a loop that's going to take us from 0 to 1 less than the upper boundary of that first group. So now we're going to create the individual particles. So particle sprite, and then in square brackets I. So this is going to go from 0 to 1 to 2 to 3 and so on, equals new, and here's our constructor, particle sprite, and now all of our parameters. So this is a long list of parameters, particle type 01, so that identifies what texture 2D we're going to use. And then the position X and position Y, and remember we set those up to be the center of the screen. Okay, and now we have the speed. So for the speed, we're going to do something a little more complex, because we're going to use that random number. So the random numbers, and we're going to, once we get the random number, turn it into a float. So float rand dot next, open paren, lower boundary particle speed, then upper boundary of particle speed, divided by another random number. So rand.next again. We've already converted this to a float at the start, so we don't need to do anything here. And then we're going to set this random number between 1 and 200. There we go. Okay, so that was the X speed. And now for the Y speed, we're going to do basically the same thing. Okay, and this is just trying to get as much randomness into these particle speeds as possible so that they don't have any apparent pattern as they're flying away from the center. So that's that, and then the next parameter is the bool active, which we set to true, which means this particle is going to render once the reaction has happened. Now we have the scale. And again, this is going to be a random number. And remember, 1 means 100%. So between 1 and the upper boundary of the particle scale, which is, I believe, 1.01. And we're dividing this by 80, which we're putting the F on the end, which makes it a float. And the next parameter here is gravity. So we're coming up fine somewhere here. There we go, particle gravity. And the next one is the rate. And remember, this is the rate of change in the particle scale. So how quickly the particle's getting larger. And that's all the parameters. That's quite a lot of parameters. We've got a lot of randomness in there so that this looks like a true random explosion. So we have our ending curly there, and now we'll skip ahead. Okay, so now we've skipped ahead. We've got all of our different segments here, and these are almost identical. The only difference is the upper bound and lower bound that we use and the particle type numbers. So you see it goes from 1 down through 7 here. So other than that, they're pretty much all the same. The random numbers are going to take care of the size and speed and all being different. I'm going to get rid of these extra spaces here and save it. And that's it for those setup methods. And next we're going to deal with the methods that are part of the game loop.